Here we have to write the polynomial given these zeros. So we have one imaginary, which is impossible. Where there's one, there's got to be a second. So there's always going to be a plus or minus with imaginaries. So there are 4 zeros. My final answer should be a degree of 4. So this 0 produces this factor. This 0 produces this factor. And then x minus a minus 3i and x minus a positive 3i. Okay. There's the 4 factors for the 4 zeros. I'll work with the imaginaries first. So this will just be an x plus 3i. This will be an x minus 3i. Let's distribute. You could FOIL here since it's binomial times binomial. But you'll get an x squared. You'll get a minus 3ix. You'll get a positive 3ix. And then you'll get a minus 9i squared. So recall that I squared is a negative 1. So this becomes a positive 9. These cancel. This is the binomial that would produce these 2 zeros. So now I'm going to do these 2 binomials. So that is going to be an x squared. My outside will be a minus 2x. I might as well just write it. My inside will be a plus x and then minus 2. So combining, I'll have a minus x minus 2. There's the trinomial from these 2 binomials. Now again, we have a trinomial times a bi. So 3 times 2, I should have 6 terms. And then we'll combine like terms. So x squared times x squared is a x to the 4th. X squared times 9 is 9x squared. Now I'm going to take negative x. So that'll be a negative x cubed and a minus 9x. And then I'm going to take negative 2 to both terms. And minus 18. So we have 1/4. I have a cube there. A couple squares, so those are going to combine to make a positive 7x squared. And one linear and my constant. So you can always check, put this polynomial inside our calculator. So I'm going to do that now. I got a lot in here. So clear, clear, clear. And it is x to the 4th minus x to the 3rd plus 7x squared minus 9x minus 18. So graph. This should cross the x-axis at our originals at negative 1 and 2. So negative 1 and 2 sure looks like it. Negative 1 and 2, got proof. So with 2 reals and it crossing at the right spot, I am confident this is the polynomial that produces those 4 zeros. Just remember, if you got an imaginary, you'll have its pair. Okay? That'll be for this one here, 24. Try it on your own, or you should have over the weekend. And I'll talk to you guys soon.